Aliens today are known as a scientific topic, widely researched in many countries around the world. There are countless different opinions and views about their appearance in the flow of human history. Most believe that they came to Earth and helped us in the process of building ancient civilizations. However, others suggest that aliens came here billions of years ago. They came to Earth in small form, without tall, thin bodies, pale skin, or modern spaceships. Then, when they awakened in a suitable world, they quickly multiplied and evolved until today. And if you want to know what they look like, you just need to look in the mirror. The story I just told is a symbolic image of the problem of the origin of life on Earth. Most likely, everything that lives around us is made up of life germs that do not originate from this planet. This seems like a myth, but it is extremely well-founded. The question we need to solve is, how did those life germs get here? And why could they form and exist in the universe? All will be answered in the next 30 minutes. Aliens Journey from the Stars. From the first Earth, don't hesitate to give us a like and a channel subscription right now. I hope you are ready, so let's get to the main content. More than 4 billion years ago, the Earth's surface was very different from what we see now. The planet is filled with water. A giant ocean covers everywhere. No continents exist. That ocean of water is no more than 30 meters deep in different areas. Countless volcanoes erupt streams of molten material, creating several small islands. The atmosphere at this time is a cloud of ash and many toxic gases, and is completely unsuitable for living organisms. Right now, a spaceship from outer space slowly approaches Earth. It is carrying very special shipments of goods. They are capsule-shaped capsules about the size of a small four-wheel drive car. Inside each capsule are billions of living germs capable of multiplying and developing. They don't even have a nucleus, but they carry within them an extremely important treasure for life: DNA. The spaceship door opened, and the capsule containing life germs launched to Earth. Immediately after completing the mission, the ship carrying the remaining life seeds left for other suitable planets. The flaming life capsule plunged into the atmosphere, but this was no big deal. It is inherently designed to resist such physical impacts. It collided with the ocean's surface, creating a violent explosion, scattering life everywhere. Most single-celled organisms will die in water immediately because the temperature is very high. But some surviving organisms will thrive around underwater craters. Organisms adapt and evolve to be more diverse. So small islands from lifeless, barren rocks have the opportunity to turn into rich, bustling oases. Those who sent that germ of life knew that it would take several billion years for intelligent life to develop from the DNA of those first single-celled organisms. Now back to reality. What if we replaced the alien life capsule with an asteroid or comet from outer space? The answer is that the scenario of life development will also take place similarly to the later part of the story and shape our world today. More and more scientists believe that life on Earth was not born on this planet, but originated from outer space. That theory is called panspermia. According to this hypothesis, life on Earth developed in other areas of the universe and entered Earth through comets or meteorites colliding with the Earth's surface. Although there is still no clear evidence to support this concept, important discoveries in the last century have made the panspermia theory more feasible. So what have we discovered? The person who proposed this hypothesis is the man you are seeing. Svante Arrhenius, the famous Swedish chemist, won the Nobel Prize in Chemistry in 1903. Before the panspermia theory was born, the theory was accepted. The origin of life is a biological process in which inorganic matter forms organic matter, named the primordial soup pot. This took place about 3.5 billion years ago. At that time, simple organic molecules appeared through interactions between substances and energy sources in many different forms. They accumulated more and more, forming a soup of the primitive ingredients for life, and through further processes of reaction and transformation, real life was formed. However, For life to proliferate and develop, according to the panspermia hypothesis, it must originate and form from space. Is this possible? Life in outer space is really difficult to exist, even in its most basic form. To test the ability of life to endure harsh conditions, Originate exposed microorganisms to deadly cold temperatures in the laboratory, near 0 degrees Kelvin. If these bacteria really come from space, they may be able to adapt to such temperatures. 0 degrees may not sound too extreme. However, we are talking about temperatures colder than the coldest places in the universe. The result of the experiment was that no living creatures survived. Originate was very disappointed with this result. However, a ray of light flashed as he slowly increased the temperature. With gradually warming temperatures, most organisms remain unresponsive, but some are activated. The miracle happened. They are still alive. The ability to survive in such unimaginable cold is certainly not natural selection. Earth has never had such cold environmental conditions. This seems to be an ability developed in another world. Organisms capable of surviving in such extreme conditions are often called extremophiles or extremophiles. When humans learned of the existence of such creatures and began searching, they found that life appeared everywhere. Through experiments, we know that life can exist in extremely low conditions. But what about extremely high temperatures? In 1977, scientists discovered many hydrothermal vents on the seabed. A hydrothermal vent is a fissure in the planet's surface that creates a body of water heated by geothermal heat. Hydrothermal vents are often found near active volcanic areas, places where tectonic plates are moving away from each other, ocean depressions, or hot spots. Hydrothermal vents are very common on Earth because the Earth is both geologically active and has large amounts of water on its surface and in its crust. Common forms found on land are hot springs, hot pools, and smoky mouths. Perhaps the most famous terrestrial hydrothermal vent is Yellowstone National Park, USA. Undersea hydrothermal vents are called black chimneys. The areas around hydrothermal vents on the seabed, they are biologically diverse places, often home to many complex organisms, nourished by chemicals dissolved in water bodies. There, ancient chemosynthetic bacteria form the base of the food chain, feeding many different creatures such as giant tube worms, bivalve mollusks, shrimp, and sea slugs. With temperatures of more than 400 degrees Celsius at hydrothermal vents, life forms can still survive and grow incredibly. No one knows how, at such temperatures, their DNA is not broken. But there is still one more mystery of life that is equally baffling to scientists. How do these creatures survive under such terrible pressure? Humans cannot survive at great depths without protection. Normal people will only be able to withstand a pressure equivalent to 5 to 6 atmospheres. Yet the discovered organisms exist at a pressure level of 300 atmospheres. For those of you who don't know, ATM is a unit of pressure measurement, which is not part of the International Measurement System, SI. This value represents the average atmospheric pressure measured at mean sea level at the latitude of Paris, France. In addition to surviving in extremely cold or hot environments, organisms can also survive in acidic environments, hypoxic environments, or any other extreme conditions you can think of. But is that enough for life to exist in space? Space is a harsher environment than anywhere on Earth. There is no atmosphere to protect from solar radiation, and the temperature range varies by hundreds of degrees Celsius. More dangerous than radiation or temperature is the vacuum itself. Space is a vacuum environment with no pressure created by air molecules affecting the body. Air pressure will determine the temperature that causes the liquid to boil and turn into a gas. But because in space there is virtually no atmospheric pressure, the boiling point of liquids drops significantly. As you can imagine, with 70% of the human body being made up of water, this would be a serious problem. Blood, sweat, tears, and watery tissues will boil and evaporate immediately. The vacuum of space will also suck the air out of your lungs in an instant. The constant boiling of body fluids will also create a cooling effect. The evaporation of water molecules absorbs heat energy from your body and causes parts near the nose and mouth to completely freeze. Humans cannot survive more than a few minutes in space without protective gear. However, there are animals that can do that. In 2007, more than 3,000 tardigrades were sent into space by the European Space Agency in 12 days. Initially, they did not expect any individual to return alive. Look here. This rather ugly-looking creature you are seeing is the tardigrade, the most difficult animal to kill in the world. It has existed on Earth for about 530 million years before dinosaurs appeared. They are a species with somewhat bizarre characteristics and have been an interesting and important research topic for scientists for many years. This species can withstand temperatures near absolute zero to above the boiling point of water, pressures 6 times the deepest point of the seabed, ionizing radiation hundreds of times lethal levels, and the vacuum of space. It can survive without water or food for many years, even when its body is only 3% water or less. Due to the above unbelievable abilities, tardigrades are found all over the world, from the Himalayas at an altitude of over 6,000 meters to the seabed deeper than 4,000 meters. After 12 days on the space mission, 68% of the 3,000 tardigrade returned intact. Not only are they not destroyed by the outer space environment, but they also continue to reproduce into new generations. With all that humans have found, it is clear that life can completely appear outside the universe. It is completely reasonable for them to reproduce and exist in certain meteorites or planets, falling to Earth through collisions. However, to be transported throughout the universe, life germs must exist for millions of years, and that seems very unlikely. How do we explain the time problem? In 2020, scientists found a piece of sedimentary rock on the ocean floor. The rock is located at a depth of more than 4,000 meters and is more than 100 million years old. They placed it under a microscope to observe and were extremely surprised to see that it was filled with paralyzed microorganisms. That's right, they haven't completely died and become fossils. They're just dormant. They tried to revive those creatures and received unimaginable results. The 100-million-year-old microorganisms not only woke up as expected, but also began to multiply immediately. After 68 days, results reached 1 million cells per cubic centimeter. It is not only a big discovery, but also enough to prove that life can sleep for hundreds of millions of years when moving between planets. But we know life on Earth began billions of years ago. A 100-million-year-old germ is still not enough to convince that its origin is from outer space. Now let's recall the primordial soup view we mentioned at the beginning and focus on the key point that life arose 3.5 billion years ago. At a time more than 3.5 billion years ago, life could not exist because the conditions were too harsh. But is this correct? Earth was formed about 4.5 billion years ago. The earliest period is called the Hadean period, or the Great Fire, referring to the period when the planet was still in the form of gas and dust clouds that had not yet completely merged together. The whole planet felt like hell. The Earth is so hot that rocks cannot solidify to form a solid enough surface. This is clearly an unreasonable period to search for evidence of life. Continuing through this period, we come to the second period, where we are in the Archean geological period, where the crust solidifies and oceans appear. The atmosphere is a mixture of methane and ammonia, along with many other substances. The conditions were not ideal, but they were enough for life to begin. But how do we prove that? Today, it is amazing that there are places on Earth that still preserve rock samples from a geological period nearly 4 billion years old, such as the Isua Greenstone Belt in Greenland. In 2016, researchers announced the number of ancient traces of a 3.7 billion-year-old living creature found in the southwest region of Greenland. Following this, the research team argued that the morphology, chemistry, mineralogy, and layers of the fossil fragments, ranging in size from 1 to 4 centimeters each, were traces of stromatolite fragments. Stromatolite, which means stratigraphic layer in Greek, is a stratified biochemical structure formed in shallow water by trapping, binding, and cementing sedimentary particles by biofilms. From microorganisms, especially cyanobacteria, they can be found in freshwater or saltwater bodies and evaporite sediments in different places on the planet. This proves that life began much longer than the 3.5 billion years previously believed. If that's not enough to convince you, follow me to another place, Jack Hills. The rocks here were formed as far back as the primitive hellish period we just talked about, the Hadean period. Scientists discovered that although it showed no signs of life, there were zircon crystals present. Zircon is an extremely unique material among all materials born on Earth. It grows in volcanic rock and, although thinner than a human hair, it is nearly indestructible. Zircon even lasts longer than the volcanic rocks that nourish it. Zircon is a mineral belonging to the red silicate group. Zircon combines molten silicate and some other unconcentrated, unmixed elements and accepts elements with high field strength to form its structure. The crystal structure of zircon is a tetragonal crystal system, and the natural color varies from colorless to golden yellow, red, brown, blue, and green. Recently, scientists have discovered a zircon crystal at a sheep farm in Jack Hills, Western Australia. Through testing, researchers determined that this crystal is 4.4 billion years old, making it the oldest solid specimen known to date. Analyzing samples, geologists believe that zircon crystals were born in a fury of molten rock not long after the Earth was formed. It is true that no living organisms will be found in a crystal more than 4 billion years old, but organic carbon will be. That's right, biological carbon more than 4 billion years old partly proves that life developed in harsh conditions equivalent to Hadean before oceans of water covered the Earth's surface. In a time when we do not have a strong enough atmosphere, meteorites are even more likely to attack and collide with the planet. The panspermia theory says that meteorites are what seeded life on Earth, and with new discoveries, it's increasingly plausible. For many years, the panspermia theory that comets and meteorites were the origin of life was left out of scientific discussion. People consider it an unrealistic and unfounded theory. But now, with discoveries about ancient life, everything has changed. However, even if meteorites were somehow able to strike Earth, many years ago we had never found any form of life on meteorites.